everyone, it's me again, Liz. Welcome to my channel. Today we'll talk about solving quadratic equations, specifically on the difference of two squares. If you are new to my channel, I'd like to invite you to subscribe. Hit the subscribe button and don't forget to like and share this video as well. Okay? Before we proceed to solving quadratic equations, I'd like to let you know that there are actually many ways to solve quadratic equations. Some of those would be by factoring method. We also have the quadratic formula. We can also use completing the square method, or we can do the graphing technique. But today, I'm going to be focusing on the factoring method. And actually, this is going to be in two videos. All right, so watch out for the next video still about factoring. All right, but before anything else, let's review what are the factors of a number or of an algebraic expression. For example, you have 50. The factors 50, sorry for that, 50 and 1. When you multiply 50 and 1, it goes back to 50. Therefore, 50 and 1 are factors of 50. What else do we have? We also have negative 50 times negative 1, because negative times negative would be positive. Therefore, we would go back still to the number 50. Therefore, negative 50 and negative 1 are also factors of 50. What else do we have? We also have 25 times 2. It's still 50, therefore 25 and 2 are factors of 50. What else do we have? We also have the opposite, negative 25 times negative 2, also factors of 50. We also have 10 times 5. When we multiply them, you would go back to 50. Therefore, 10 and 5 are factors of 50. And there are still many factors that I cannot write down here with the number 50. I just want to explain to you what does factors mean in math. Okay, now let's go to the algebraic expression x squared. How do we factor variables? So simply think of variables that when you multiply, you go back to x squared. So we have x times x, right? So if you have x times x, according to the laws of exponents, when you multiply two variables of the same alphabet, or two variables that are the same, you simply add the exponents. Okay, therefore, x and x are factors of x squared. What else do we have? We also have negative x times, this is multiplication, negative x. That would also end up to x squared. Why? Because negative times negative is positive, and x times x, they actually have an exponent 1, both of them, and since we are multiplying the same variables, we should add the exponents. All right, and finally, what are the factors of 64? There are actually a lot, but we'll just name a few. 64 and 1 are factors of 64. We have 8 times 8. We also have 16 times 4. Of course, the negative counterpart are also factors of 64. So that's the idea about factors. All right, let's proceed to our next slide and to our main topic. Let us now practice factoring the difference of two squares to solve for the roots of the quadratic equation. But first, what are some examples of squares? As I have told you in my first video, that when we talk about squares, it could be a shape with four equal sides, and in algebra, it could be a number or a variable or an expression. All right? Some few examples are these numbers. They are examples of squares. Sometimes we call them the perfect squares. Okay? Why do we call them the perfect squares? Because their factors are a number multiplied by itself. Okay? So for example, 1. The factors of 1 would be 1 times 1. And we can rewrite it as 1 squared. How about 25? So the factors of 25 are 5 times 5, which can be written as 5 squared. That's why it's called a perfect square. And all of these numbers are actually examples of squares. 100 is 10 times 10. The factors are 10 and 10, which can also be written as 10 squared. With these variables, x squared, y squared, obviously they are perfect squares because of the exponent here. And 4a squared and 25x squared, they are also perfect squares because 4, as we can see here on the left side, 4 is a perfect square, and 25 is also a perfect square. So if we factor them, it could be written as, let me erase that real quick. It could be written as 2 squared times a squared. Okay, so 2 squared and a squared are factors. It could also be 2 times 2 times a times a. And 25 would be 5 squared squared. All right, those are just examples. There are infinite numbers of examples for perfect squares. Okay, I just want to refresh your mind about perfect squares and factors before we finally proceed to our examples and how to solve for the roots of any quadratic equation in the form of the difference of two squares. Okay, but why is it called the difference of two squares? Because our equation have two terms. Let's take a look at number 1. We have two terms, and both of them are perfect squares, and the operation in between is a minus. We all know that the word difference means that we are subtracting two terms, correct? All right, so for number 2, also two terms which are perfect squares, and the operation is minus. How about number 3? It doesn't look like there's a minus sign there. It says a squared equals 100 in number 3. Well, we can actually rewrite it in a way that we can put 100 on the left side of our equation and leave a 0 on the other side. Now we know properties of equality that when we move one quantity from the other side of the equal sign if it jumps to the other side, the sign changes because of what we call the property of equality. Actually, this is because if we get rid of 100 here, I'm going to subtract 100 on this side and 100 on this side. Why? Because according to the property of equality, whatever you do on one side of the equal sign, you should also do on the other side of the equal sign for it to be still an equal value, okay? So 100 minus 100 would be 0, and this side here becomes a squared. We just have to copy because we cannot combine them. All right, so that's it. For number 4, 4d squared is a perfect square. 144 is a perfect square. And the difference or the operation is minus, therefore it's the difference of two squares. Solve for the roots of the following quadratic equation. For number 1, we have x squared minus 64. The first thing we need to do is to draw two sets of parentheses. When your teacher asks you to solve problems like this, you have to do it this way. I mean, it's always like this, all right? So first, let's get the factors of x squared. We have x times x. And then, let's have the factors of 64, but this is a perfect square, so factors are 8 and 8, okay? Now, the last thing you need to write is a plus here and a minus here. Or you might want to start with the minus here and plus here. It's up to you. As long as it's always a plus and a minus. Okay, it cannot be both plus or both minus. The next thing I'm going to do is I'm going to equate my factors. X plus 8 to 0 and x minus 8 equals 0. This is because of the zero product property, where it says if we have A times B equals 0, then A should be equal to 0 or B should be equal to 0. All right, that's where I got this concept. Now the final step is to solve for x on both our factors here. How do we do it? I'm going to get rid of my 8 by subtracting 8 on both sides. So that's 8 minus 8, 0. So I'm left with x here. 0 minus 8 is negative 8. Here, I'm going to get rid of my negative 8. So I'm going to add 8 on both sides. This is canceled out. I'm left with x. 0 plus 8 is 8. Therefore, my answers for number 1 are x equals negative 8 and x equals 8. All right? That's for number 1. I'm going to erase this. Let's go ahead and answer number 2. We have, I'm going to use 3. Then, let's draw two sets of parentheses first. And we're gonna write the factors of y squared, which are y and y, because y times y equals y squared. And the factors of 15, this perfect square, the factors would be 4 times 4, or 4 squared. And then what did I tell you to do? Next is to put plus here and minus here. Or you can do the other way around, minus first and then plus. And I'm going to equate both factors to 0. Okay. So y minus 4 equals 0. Finally, if I subtract 4 here, by property of equality, whatever I add on one side of the equal sign, I also add on the other side of the equal sign. That's y equals positive 4. Therefore, my answer for number 2 are y equals negative 4 and y equals positive 4. Okay. How about number 3? Number 3, we have to rewrite this equation. This actually is the same as a squared minus 100 equals 0. Okay, since we have the difference of two squares now, let's write our parentheses here. I have Since our variable is a, the factors of a squared would be a times a. The square root or the factors of 100 would be 10 and 10. I'm going to put this, I'm going to put minus first and then plus. It doesn't matter which comes first. Okay? And I'm going to equate them to 0, a. Now, if you would notice, we're just going to be switching the signs of our 10. Okay, sorry. A is equal to 10 and A equals negative 10. Okie dokie. I hope it's clearer to you by now. It's always like that in math. It's only on the very beginning that a topic is somewhat confusing, but over time with more practice, you'll be able to understand more about a topic. All right, let's go to our last example. This one is a little bit different from the rest, but we'll see what we can do here. I'm gonna write 2 sets of parentheses. And this time, since I have a 4 before d squared, I'm going to include that in factoring. So the factors of 4d squared would be 2d and 2d, because 2 times 2 is 4, d times d is d squared. All right, how about 144? The factors of 144 would be 12 times 12. Now I'm going to put minus here first and plus here. Again, it doesn't matter which comes first. So I have my factors now. All I'm going to do is equate them to 0. Equal 0. This 2d plus 10 equals 0. Now, since I have 2d minus 12 equals 0 here, I'm going to get rid first of the 12. So I will add positive 12 on both sides. So I have 2d left here and 12 here. To get rid of 2, I'm going to divide both sides by 2. Okay, cancel. So I'm left with d equals 6. And here I have, oops, this is supposed to be 12. Okay. All right, so we have 12 here. So this is going to be minus 12 here, minus 12 here. I have 2d, that's canceled out, equals negative 12. Divide both sides by 2. I have d equals negative 6. So my answer for number 4 is, I hope that you can clearly see it. D equals 6 and D equals negative 6. That's it. I hope you would subscribe to my channel, and please don't forget to hit like and share this video. Watch out for the next one. It's going to be about solving quadratic equations with rewriting first to standard form. So see ya!